Hi, I'm Denise, and you found Math for All to learn more about math. Today's video is on something called the distributive property, which is used to unlock terms inside parentheses, so it is pretty powerful. Also, it's often your first step in solving algebra equations, so it's important. And it can help us multiply big numbers in our heads so we can look smart. The distributive property distributes or shares with everything inside the parentheses. They look like these. Today, I'll cover many different aspects of the distributive property, such as some special cases, showing it visually with rectangles, and how to use it to multiply those big numbers in your head. Before we get started, please print out the fill-in-the-blank notes that follow this video from my website, mathforall.net, which will really help you absorb this concept, and it will be kind of fun too. To show you how this works, we will solve 6 times 3 plus 7 two ways. First, using our order of operations, we will need to do what's inside the parentheses first. 3 plus 7 equals 10. Now, there's invisible multiplication in between the 6 and the parentheses, so we'll multiply 6 times 10 for an answer of 60. That wasn't so bad. Now, let's use that distributive property. I like to do rainbows from the first number to the inside numbers. We will multiply across these rainbows. 6 times 3 plus 6 times 7. We'll drop that down here and do the multiplication first and then add. 18 plus 42 equals 60. Either way you slice it, we get the answer of 60. You may be thinking, that's great info, but what's the big deal? It sure doesn't look like much right now because we can just add or subtract whatever's inside the parentheses first. But from now on, we will usually have things that look like this. -6 times 2x plus 7. Sound the alerts. This is a major problem. 2 plus 7 cannot be added. They are not like terms. So they are locked inside that parentheses. Their only hope of escape is to distribute the number in the front to both of the terms inside. This will be our first step in many algebra problems. Get those terms unstuck from the parentheses using the distributive property. Let me show you what I mean. I have 3 times parentheses 8x plus 5. Sometimes that's also stated as 3 times quantity 8x plus 5. Order of operations says that I need to add 8x plus 5 first, but they are not like terms and they cannot be combined. Our other option is to distribute the 3 to both. I draw some rainbows here, and I multiply across the rainbows like this. 3 times 8x plus 3 times 5. There's no more need for the parentheses, and now we do some math to completely simplify this. The first term is 3 times 8, 24, with an x after it. Then 3 times 5 is 15, for 24x plus 15. Let's practice one with some negative numbers to help you determine whether the answers are positive or negative. Take a look at this. -6 times quantity 7z minus 3. I'm going to circle each of these terms with their signs in the front that are attached to them. Draw rainbows and multiply across those rainbows. -6 times 7z first. Then let's put a plus after it. Then we have -6 times -3. Now we can simplify each of these by multiplying. -6 times 7z is -42z. Then -6 times -3 is positive 18, so we write plus 18 for -42z plus 18. Next are 2 special cases that you often see on tests. Our first special case is when we have a positive or a plus sign right in front of the parentheses, like this one. This looks creepy and weird, but watch what is really going on. The plus is really a +1 in front, like this. When I multiply across rainbows, it's just +1 times each of the numbers. 1 times 10y is just 10y, and 1 times -73 is -73. So really, the parentheses were not necessary, and we're back to the same numbers we started with, 10y minus 73. This is true anytime you have a plus with no number right in front of the parentheses. Here's the second special case. It's when we see a negative or a subtraction right before a parentheses. This time, I must see that the negative sign is really a -1 in front. So all of the things inside the parentheses must be multiplied by -1, which honestly will just change the signs of all the terms on the inside of the parentheses. -1 times 2b equals -2b. -1 times -11 equals +11. One common error is to not distribute the negative sign across both terms, so don't forget to do that. As you can see, the distributive property distributes the number in front to everything inside the parentheses. Here's a visual with rectangles as to why this is legal. Take a look at this big rectangle that is also split into 2 rectangles. The width or height is 4. And across the length or base is 8 here and 3 for this part. I will find the area 2 ways. First, I will look at it as one big rectangle. The area of a rectangle equals length times width. I'm going to put the width first because it helps my equation look like what we're already familiar with, 4. That times our length, and our length is 8 plus 3. I need to put that in parentheses because it's 4 times whatever my length is, which is 8 plus 3. Add it up. 8 plus 3 equals 11. My area is 4 times 11, which is 44. The second way I will find the area of the total shape is by finding the area of each of the smaller rectangles and then adding those areas together. The red rectangle's area is 4 times 8 for 32. The yellow's area is 4 times 3, or 12. Add those areas up to find the area of the whole rectangle. 32 plus 12 equals 44. This shows that 4 times parentheses 8 plus 3. The 4 distributed to both, 4 times 8 plus 4 times 3, it's pretty cool. That's it for colorful pictures today. On to how this property can help you multiply larger numbers in your head. It's a trick you can use instead of long multiplication, and it makes you look smart. It can be used for something like this, 7 times 32. I'll write out the steps, and then we'll do this one together so you can see what I mean. First, pick one of the numbers you are multiplying, usually the bigger number, and break it up using plus or minus into easier numbers. I define easy numbers as any single digits or numbers with zeros on the end. Second, put your broken up number, if you remember expanded form from a long time ago, that's what we're doing, in the parentheses and use the distributive property to solve. Let's tackle this 7 times 32. I will break up that 32 into 30 plus 2. I'll copy the 7, then start my parentheses 30 plus 2. Rainbows, then 7 times 30 equals 210. Do you remember the trick to multiply when there are zeros on the end? You ignore the zeros, multiply the numbers, and then you put those zeros back into the answer. It's super helpful for these. Then we have 7 times 2, which is 14. 210 plus 14 equals 224. I can sense that some of you that don't like writing down too much may really use this a lot. Let's practice another one. We'll actually figure it out twice by splitting both of the numbers to show you that it doesn't matter how you slice it, it'll still work. 11 times 96. I'll follow the steps and write it out, but normally you could do this in your head. My first step says to break up the bigger number, so I'll choose to break up the 96. I actually could make it into 100 minus 4, but honestly, I think that makes it harder if we incorporate subtraction. So let's just expand it into 90 plus 6. Here's where we're at. 11 times quantity 90 plus 6. 11 times 90 equals 990. 11 times 6 equals 66. Now we have 990 plus 66. To do this in my head, I will add 10 to the 990 to get to 1,000, a very nice, easy number. That took 10 of my 66, so now I have to add 56 more. 1,000 plus 56 is 1,056. That was using some great number sense. I feel like the hardest part of that was that mental addition. Then that means the distributive property is getting good. I promised I would do it another way so you don't get concerned about the major life decision on which number to break up. 11 times 96. This time we'll break up the 11. I love how easy these numbers turn out. 11 becomes 10 plus 1. 96 in the front. 10 plus 1 in parentheses. 96 times 10 is 960. 96 times 1, 96. 960 plus 96 equals 1,056 again. You get to decide which one of those was easier, but go ahead and practice some for fun. Our final topic today is using the distributive property to simplify expressions. For these, we use the distributive property to get those terms out of the parentheses. Then we will add any like terms that we see. Look at this one. 7 times x squared minus 4 minus 3x squared plus 5. The first thing to do is to distribute the 7 to the first group and the negative sign to the second group. I like my rainbows to remember that it goes to both things inside the parentheses. 7 times x squared is 7x squared. 7 times negative 4 is negative 28. On to the negative sign that you can either think about as a -1 or just remember that it changes the signs of everything inside the parentheses. Either way, these become negative 3x squared and negative 5. Notice the like terms that we have here, 7x squared and negative 3x squared, that combine to be 4x squared. And the numbers negative 28 and negative 5, which add to negative 33, for an answer of 4x squared minus 33. Great work on that one. You are really getting this. I hope you can appreciate the superpowers of the distributive property after watching this video. Just remember to distribute that first number and its sign to everything inside the parentheses. Don't let them fool you with a plus sign in front. It makes the parentheses meaningless. And have fun with trying to multiply larger numbers in your head using that technique that I showed you. Next step is using the distributive property to simplify both sides of an equation and then solving for x. But before you tackle that, please go to my website, mathforall.net, and print out and complete a worksheet that has practice problems with all the different aspects of the distributive property that you learned in this video. Then watch some more videos to keep learning more about math. See you later. Oh, as the alligators say, ah, yeah. That's what my kids used to do. What does the elephant say? We had way too much fun. Just like with math videos.